Good evening, everybody. Welcome back. We are going to finish the first half of Chapter 6 by talking about solving exponential functions using like bases. So first we need to figure out what is an exponential function. An exponential function is when you have a base and the exponent, some part of it, has to be a variable. The reason why this is important is because if we had x squared is equal to 36, we know that we could take the square root and find out that x is 6. If we had x cubed is 8, we could take the third root and find out that x is 2. But when I have 3 to the x is equal to 5, well, I don't know what root to take because I don't know what exponent I have. I can't divide by 3 because I'm not multiplying by 3. So this is where we have to take a different approach to solving. And our very first step is to start with when we have like bases. So like bases means that your two bases, I'm going to rewrite that over here, we have 3's. They're exactly identical. So because our bases are identical, we can look at only their exponents and say x is equal to 5. If the bases are equal to each other, the exponents have to be equal to each other. We also want to do a quick refresher of what the negative exponent rule is, meaning if we had 3 to the negative first power, remember, negative exponents don't make negative answers. They take the reciprocal of whatever you have, or flip it. So right now, this is technically 3 over 1. The negative exponent rule would make that 1 over 3 to the positive first. If I had 1 over 3 to the negative first, remember that negative takes it and flips it, the reciprocal, and makes that 3 to the positive first. If we had 2/3 to the negative first, then that whole fraction is going to be flipped around, the reciprocal, and it'll be 3/2 to the positive first. So I wanted to go back over that one more time as a refresher before we continue on. Let's try some. The first question is, are the bases the same? And in this case, they both are. They're both 2. So because they're both 2, we can ignore the 2's for right now and look to their exponents. On the left side, we have x. On the right side, we have 7. X is equal to 7. That makes sense because if I replace the x on the left with 7, then that looks exactly the same as the number on the right, 2 to the 7th. Letter B, though, I don't have like bases. I have a 4 and a 16. So my question is, can I change that 16 into a base 4 with some exponent? So do I know 4 to what power makes 16? And I do. That's 4 squared. So we rewrite 16 as 4 squared. By doing that, now my bases of 4's are the same, and that means that we can look at the exponents and find out that x is equal to 2. Letter C. Our bases are both e. Awesome. So since we have like bases, we can bring their exponents and just focus on those to say x minus 3 is equal to 2x plus 1. Well, now this is just regular old solving. I'm going to bring my like term x over with the 2x. And then I'm going to bring my like term of 1 over with the negative 3. And I get x is equal to negative 4. All right, I have a base 3 and a base 9. Those are not the same. So I want to try, because 3 I can't really do anything with, but 9, can I change 9 into a base 3? And I can change 9 to 3 squared. That 3x minus 2 is still out there in the exponent. And our exponent rules for this, when they're both exponents up to each other, are to multiply. So I'm multiplying the 2 by the 3x minus 2, which really means we're distributing. So 2 times 3x is 6x, and 2 times negative 2 is negative 4. Now, my bases are the same. They're both base 3. That means I can bring down the x, and I can bring down that 6x minus 4, and I can solve. I'm going to bring 6x over to its like term of x. So negative 5x is equal to negative 4. Divide both sides by negative 5, and we get x is 4/5. Letter E. I have 16 and 64. Well, can I change 64 into 16 squared or 16 cubed? And the answer to that is no. That's going to be too big of a number. So I need to bring down both of these to a smaller number. Well, we changed 16 to 4 squared earlier. 4 squared was 16. You still have that x plus 3 up there. So 64. We can use our calculator, and we find out that 4 to the 3rd power is 64. All right, exponent rules, again, say over here on the left, I have to distribute that 2 to the x plus 3. So we get 4 to the 2x plus 6 equals 4 cubed. So now my bases are both 4s, which means we can just look at the exponents to say 2x plus 6 is equal to 3. Solve for x. I'm going to subtract 6 to the other side. We get 2x is equal to negative 3. Divide by 2. And x is equal to negative 3/2. Letter F. All right, well, I have a fraction on the left side and a not fraction on the right side. So I want to start with taking this left side and not making it a fraction anymore. In order to bring that 36 so that it's not underneath a 1, we use the negative exponent rule. So we change that to 36 to the negative first power. We haven't changed the x minus 7, and we haven't changed the base 6 on the, on the right side. That should still be a 3, sorry. But they're still not like bases. I have a 36 on the left and a 6 on the right. So, can I take 36 and make that into a base 6? Yep, I can if I make that 6 squared. So 2 times negative 1 is negative 2. And then I'm going to distribute that negative 2 to the x and the 7, which gives us negative 2x plus 14. Again, I haven't done anything on the right side because I already had a base 6. So now my bases are the same. Sorry, I ran out of space there. So we had 6 to the negative 2x plus 14 and 6 to the x plus 3. Since our bases are the same, we can look at just the exponents and say negative 2x plus 14 is equal to x plus 3. And now I'm going to solve. I'm going to add my 2x over to the right side. So that gives us 14 is 3x plus 3. And then I'm going to subtract the 3. So we have 11. Sorry about that. Equals 3x. Divide by 3. And x is 11/3. All right, listen up. On the back side of this is column 1, column 2, column 3, column 4, and column 5. I don't know why I'm not able to write here. Sorry about that. So if you are in first hour, you're doing column 5, second hour, column 1, fifth hour, column 3, and sixth hour, column 2. And it's just these 4 questions, depending on which column it is that you need to do. That'll be the rest of your homework points. Have a fantastic rest of your night.